Welcome you all. In this session, we are going to discuss the problems related to designing induction machine. Problem: design a 30 HP 3-phase 440 volt 960 rpm 50 Hz delta connected squirrel cage induction motor. Assume specific electric loading as 25,000 and specific magnetic loading as 0.46 Weber per meter square. Full load efficiency of 86% and power factor 0.87. Calculate the following: stator core dimension D and L, number of stator slots and winding turns. So in this problem they have mentioned you are supposed to find the stator core dimensions, that is the main dimensions of the induction machine, D and L in meters. Then you are supposed to design the stator slots and number of turns in the windings. Okay, so first you need to take the given data. So if you see the given data, the rating of the machine is given in terms of HP, so you need to convert it to kilowatt, followed by the voltage rating, the speed as well as the frequency has been given. Specific loadings values are also mentioned. So first, initially the very first step is you need to convert the rating of machine from horsepower to kilowatt. So nothing you need to do, just you need to multiply it by 0.746. so once you multiply it, you will be getting the value in terms of kilowatt. So I have multiplied it, so I'll be getting a value. So the next thing is efficiency is mentioned in terms of percentage, so I need to convert it into a decimal value which is equal to 0.86. so the power factor, which is 0.87. the input kVA is, so first step is you need to calculate the kVA rating of the machine. So kVA rating is nothing but kilowatt rating divided by power factor into efficiency. So this is the formula to calculate kVA rating of machine. So I have substituted the value of the power rating of machine in terms of kilowatt divided by the efficiency and power factor value. So the value which I am getting is around 29.92 kVA. This is the kVA rating of the machine that they have mentioned. So we also have also given the specific electric and magnetic loading. The specific electric loading value is 25,000 and specific magnetic loading value is 0.46 Weber. So again the stacking factor is 0.9. So the output coefficient, first let us calculate the output coefficient. What the formula to calculate output coefficient is 1.11 pi square B average AC kW into 10 to the power minus 3. So substitute the values. So while substituting, I'll be getting an expression 1.11 into 10 to the power into pi value is 3.14 square times into 0.46 into 25,000 into 0.9 into 10 to the power minus 3. So the value which I am getting is 120.3. so the output coefficient is 120.3. Now the speed is given in terms of RPM, so I need to find the speed in terms of RPS, rotations per second. So just I need to divide it by 60. So speed is given as 960 rpm. So while dividing, I'll be getting 960 divided by 60. I'm getting a value of 16.67 rps. So the number of poles is, so with the help of frequency you can find the number of poles. You can use the synchronous speed formula, so 2f by ns. So while substituting, I'm getting that the number of poles required is 6. So the output equation of machine is kVA is equal to, that is Q is equal to C naught D square L ns. So I need to substitute the values. So while substituting, I'm getting that D square L is equal to 0.015 meter cube. Also I'm considering here the machine is designed for overall design. Okay, so for overall design, the condition is L by tau is equal to 1. So L by tau value is equal to 1. So tau is nothing but the pole pitch. The formula to calculate pole pitch is pi d by p. So just I need to substitute the value of tau in this expression, L by tau is equal to 1. So that I'll be framing the second equation with respect to L and D. So here I have given the formula to calculate tau, that is pi d by p, the pole pitch. So I have substituted the value of pole pitch in the previous expression. L by tau is equal to 1. So I am getting an expression such that L into pole divided by pi into d, which is equal to 1. So while again rearranging the equation, I am going to frame the second equation, that is L is equal to 0.15 by d square. So this is the second equation. So now we have two variables, that is d and L, with two equations. So it is easy for us to solve those two equations with two variables. So while solving above two equations, you will be getting the value of d and L directly in terms of meters. So again already we have that d cube is equal to 0.28 meter cube. So I am substituting the value of d, so that I am getting a value d is equal to 0.3 meter and L is equal to 0.16 meter. So we can check your answer, because always we know that the value of d and L will be a minimum value which doesn't exceed 1. So always it will be a decimal value. So I am getting the value as 0.3 and 0.16. So our values are right. So again we need some more parameters to be checked. So here let us check the peripheral speed. So the formula to calculate peripheral speed is VA is equal to pi d ns. So pi value is 3.14, d value is 0.3 and ns is 16.67. So on substituting the values, I am getting the peripheral speed as 15.6 meter per second. So here it is within the limit, so the dimensions are permissible. So now B average is equal to pole into phi m divided by pi dl. So now from this phi m maximum flux is calculated. So once maximum flux is known, you can calculate the value of T phase, that is a number of turns required. So T phase is equal to E phase divided by 4.44 F phi m kW. Just substituting the values, we'll be getting the value of number of turns per phase, that is 180 turns. So you can approximate it to a whole number, because always the number of turns will be a whole number. So I need to approximate it to 180. So the total number of stator pole per phase is 3 times poles into number of phase, that is 3 into 6 into 3, which is 54 number of slots. So the slot pitch is pi d by ss. Just I am substituting the values of pi d by ss. The pitch value is 0.017. So the total number of stator slots, stator conductors are 6 into number turns per phase, that is 1080 conductors. Totally we have 1080 conductors with respect to stator. Number of slots is total number of conductors divided by ss. So I will be getting a value of 20. Total number of slots is 20, total number of conductors is 1080 and total number of turns per phase is 180 turns. So this is how we used to solve problems with respect to main dimensions in induction machine. Thank you.